And one of the things that you need to do as a hacker or network engineer is to understand some basic NMap. So let's talk about NMap right now. Why do we care what ports are open? Because if we're attacking the system, usually we're attacking the services behind the ports. It's a way to know what's being run on that system. Now I can begin the process of, say, doing Wi-Fi hacking, which everybody wants to do, right? Everybody wants to hack their neighbor's Wi-Fi, and we're not going to do that.
Hey everyone, David Bombal back with Occupy the Web. We are continuing our series looking at Linux basics for hackers. This is a fantastic book. Occupy the Web, so glad that you're doing a video series complimentary to the book. Great to have you back. What are we talking about today?
Thanks, David. It's always an honor to be back on the best IT and cybersecurity channel on YouTube. Today, we're going to talk about networking from Linux. We're going to do some simple networking and do some simple networking commands. Nothing too complex, but we're going to kind of introduce the people who are new to Linux, and what commands are key in doing any type of work over a network from Linux. So we're working from chapter 3 of my book, Linux Basics for Hackers. I also want to point out that there's not a whole lot of networking in that book. It certainly assumes a little bit of networking capability. If you're not familiar with networking, I have a book out called Network Basics for Hackers. You might want to use that as a reference.
Good book. Yeah.
Okay, thank you. And so let's go ahead and start with, I've logged in to a shell. Now, one of the things that I showed earlier is that I changed my terminal or my shell to a bash shell. You might have remembered that I did the Kali tweaks. So in an earlier episode, I showed you this command Kali tweaks. And I'm going to go back there just to kind of remind you in case you haven't seen it before. So Kali tweaks allows you can see on the fourth line here, there's shell and prompt right here. Configure the shell and command prompt. So I'm going to go ahead and you can see if I scroll down here, I'm just going to go using the down arrow key, is I can default login shell. And you can see mine has already been switched. If you're new to Kali and you haven't made this change in the most recent versions, you're probably in the Z shell. Now, there's nothing wrong with the Z shell. As a matter of fact, some people think it's superior to the bash shell. The reason that I'm using the bash shell is because if you're learning Linux, and you want to go out and use, another operating system like Ubuntu or Red Hat or Solaris, what you're going to get there is you're going to get a bash shell. And so I prefer that you learn the bash shell, and then maybe later on you can switch over to the Z shell. Most of the things will work in both shells, but let's not complicate things. Let's stick with the bash shell. My book assumes you're using the bash shell because the older Kalis had bash shell only. So I'm going to stay with the bash shell. So you can switch over, go to apply, and now I'm going to go and exit and go quit. And we're out of there. Okay. So we're working in a bash shell now. And reason I do that is that we're going to use the bash shell in a later tutorial here and write some basic bash scripts. So to be consistent with the book and to be consistent with what you're likely to see in the work, we're going to use the bash shell. And if you like the Z shell, there's nothing wrong with it. The Z shell is only being used in the Mac OS and in Kali. That's basically the only places you're going to find it. Every place else you're working in Linux or Unix, you're probably going to run across the bash shell. So let's stay with the bash shell. So one of the most fundamental commands that we're going to see in networking is ifconfig. That's interface configuration, ifconfig. And you can see that when I do that, right, I have a number of interfaces. I've got a few other interfaces on here. Yours, all right, is going to be ETH0, probably is the only one, and loopback. These others that you see on my screen are because I've got Docker and some other things on here. Well, maybe we do a tutorial on Docker in the future.
That'd be great, actually. Yeah.
Some other interfaces. Docker is becoming increasingly important. These are the ones that you are probably going to have. So let's go through what we see here. So we can see the INET. Okay, this is the internet address. Now, if you're not familiar with internet addresses, let's take a look and we'll break it down for you. And this is basic IP addressing. So the numbers are 4 sets of decimal numbers. So these are often referred to as octets because there's 8 bits to each one of them. The entire address is 32 bits. There's 1 byte or 8 bits. That's an octet for each one of these numbers. So these numbers here are decimal, base 10, representations of the base 2 or the 0 ones, okay, that are actually represented in the machine. So we have 4 octets, and that's what we have here. This is actually what's referred to as IPv4, which is the original Internet Protocol addressing scheme. We're in the process of switching over to IPv6, but that's still happening.
I was going to say, that's been happening for the last 20 years, right?
Yeah, for more than 20 years, right?
Exactly.
So it's going to happen tomorrow, right?
That's right.
For 25 years, we've been hearing that. All right.
Yep.
So that's why I'm just teaching IPv4. When everybody accepts IPv6, we'll switch over to that. Beneath it, you can see the IPv6 address. You can see it looks significantly different. Okay, but we're not going to delve into IPv6 here. Because really, most of us are still working in an IPv4 environment. And if you don't know, one of the reasons that we have these two distinctions is that originally when the internet was set up, there was only 4 nodes on the whole internet. And now, there are billions and billions of nodes. The IPv4 system is limited to 4.3 billion IP addresses, and there are 7.5 billion people on the planet, right? And many of us have multiple IP addresses, so there's just not enough IP addresses if you're only limited to 32 bits. So this address here is 128 bits, and it has a lot more IP addresses. But we'll get to that maybe in a later tutorial. So over here, we have the net mask and a broadcast address. That's maybe we should save that, but you take a look at my book, Network Basics for Hackers. But this is basically the net mask determines how many nodes we have on the network. That's what this does here. This really comes down to understanding subnetting. And then this is the broadcast address. And what this does here is it sends out, this says, if you want to talk to all of the nodes on this network, you send to this address here. And that'll send it out to all of the nodes or the clients on the network. So this is the most basic kind of command, just to understand what's going on this is probably the most important right here, is understanding what IP address we have, right? So here's our IP address.
A lot of people will complain that you don't use IP address, right? Because a lot of people are saying you should use IP address rather than ifconfig.
Yeah, so right now we're in a kind of transition between ifconfig and IP. IP is considered to be the modern way of being able to. That's either way is fine. I've been doing this a long time. I've been using IP config or ifconfig. IP config works in Windows systems. ifconfig works in Linux and Unix systems. But you can go and use the if command, which is more of a modern way of doing it. I still prefer ifconfig. It might be that I'm old school and I've been doing this a while, but I like ifconfig. And here's IP, right? And you can get the IP address and all of these other switches that you can use. Okay, these options. And so here you go. So I can go IP address.
I think it's good to mention this because, sorry to take us on a tangent, but I see that sometimes ifconfig is not installed by default, for instance, on Ubuntu.
Okay.
I know that in some distributions of Linux, you actually have to install the tools to get to use ifconfig. By default, only IP address works.
we can see that if we just did IP address, all right, instead of ifconfig, which is many people think that the if command is going to replace the ifconfig, and it probably will eventually. But on Kali, at least, it's in both of them are available to you. One of the nice things about the IP commands, you got nice colors, right? So it makes it easier to read than. And don't worry if you don't have some of these interfaces. I've installed them. This is what you should have: is the loopback and the ETH0 or Ethernet 0. Right, and you can see that we have the IP address here, okay, the broadcast address here.
Great.
Next, what I want to show you is IWconfig. And this is for wireless interfaces. So if I just type IWconfig, it will ignore all that other stuff and just show me information about the wireless interfaces. And let's go there. And you can see it comes back and says, hey, you don't have any wireless interfaces. Yep. Well, this is a question I often get from people, and that is, well, I'm connected to my Wi-Fi. How come I don't have any wireless interfaces? Well, the answer is that the virtual machine takes that Wi-Fi connection and basically converts it into a wired connection. So it goes into your host machine as a wireless, and then the connection between the host machine and this is a guest machine, your Kali here, is a wired connection. It appears as a wired. That's what ETH0 stands for, is Ethernet, not wireless. So if you want to go ahead and do like wireless hacking, you need to go ahead and put in, only if you're using a virtual machine. If you're using a physical Kali on a physical machine, you don't need to do this. It only applies to a virtual machine. So what I'm going to do is I'm going to add an external USB wireless adapter and then connect it to my Kali. And you'll see then that we'll get a wireless interface. Okay, I'm connecting it now. And there pops up the nice window that tells me, and I want to see, it says connect to the host or connect to the virtual machine. This one here is Kali 2023.3, so it's real recent. And we'll go ahead and connect it. And let's give it a minute, because sometimes these virtual machines take a minute or two to complete the connection process. And then let's go, I'm going to up arrow and do IWconfig. And you can see there it is.
Yep.
WLAN 0. Now I have a wireless adapter connected to my Kali virtual machine. Now I can begin the process of, say, doing Wi-Fi hacking, which everybody wants to do, right? Everybody wants to hack their neighbor's Wi-Fi, and we're not going to do that. I'm joking, of course.
No, of course.
Of course. But we'll look at in a later tutorial, we're going to go through in this class, we're going to go through wireless, both Bluetooth and wireless. But right now, I just wanted to show you how you can discover your wireless devices, just like we discovered our Ethernet devices. Now, we might want to be able to, say, change your IP address. Obviously, your IP address is being leased to you. That's what the term is used. Leased to you by a DHCP server. So on your network, there's a DHCP server. It's dynamic host configuration protocol, and it gives out IP addresses to everybody on the network. It's assigned to you, and then it assigns that IP address, so that when you go out to the internet, it can then match that IP address to the external public IP address. And then when the traffic comes back, it can go ahead and then match up your traffic and send it back to you. DHCP is actually a pretty simple concept, but sometimes it can trip people up. It's basically a way of giving everybody on the network an IP address and making sure that they knows what everybody's IP address is. That is what's referred to as dynamic IP address. Some cases, you may want to have a static IP address. That means an IP address that's always the same. This will come up sometimes when you're messing around in your virtual machines. For instance, if you're trying to you have a victim or target system, and you have your Kali attack system. Sometimes you might just want to put them on their own simple network with static IP addresses. And so you can change that. And there's other, obviously, we'll get into it later. There's other ways that you can use static IP address. But if you have to change your IP address, you can do so here. You can do ifconfig, all right? And remember that this is going to set you up with a static IP address, which means that your system will not be able to talk to the internet, but it can talk to other systems on your little network. So I'm going to go ahead and change mine. Mine is, what is it? I can change it to anything. I can go, let's change it to 192.168.1.101. All right. It comes back operation not permitted. And that's because I have to give it a sudo to be able to change that. I have to have the root privileges. All right. It's going to ask me for my password. And now if I go ifconfig, we should see that it has changed. Let's up arrow a little bit here, and we can see there it is.
I like it that it filled in the network mask and the broadcast address for you. That's nice.
So the problem, this will work fine on your local area network, but it's not going to allow you to go to the outside world. One of the first commands you need to know in being able to do any kind of work over the internet as a hacker or a network engineer is ping. Ping is just sending out a little packet to the target and then waiting to see whether or not it responds. It's a ICMP echo request. Then it comes back with an ICMP echo reply. I know it's a lot of terminology there, but basically all it's doing is it's sending out a packet to the target and then waits to see whether or not the target responds. That way we know that that system is actually up and running and that IP address is valid, right? So one of the things that you can always test to see if you have outside connectivity, okay, outside of your little virtual world here, is you can go ping google.com. This will always tell you whether or not, or you could have any other domain, but Google's a good one to pick on. And all this is going to do is going to send out a packet to google.com and then see if it comes back. And you can see that it does not come back. With this static IP address, I can work within my local area network, but I cannot work out on the internet. Just kind of keep that in mind. So if I want to go back to a DHCP assigned IP address, we have a command that's called DH client. DH client, ETH0, right? There we go. And what this will do is it'll go back out to the DHCP server and try to get an IP address and assign it to this interface. So IP addresses are not assigned to the machine, they're assigned to an interface. In this case, our interface is named ETH0, so that's the one we want the IP address assigned to. If we look up above, remember ETH0, right, had that IP address, right? We had changed it. Now we're going to say we want to go back to a dynamically assigned IP address that's going to give us access to the outside world. We hit enter. It says operation not permitted because I have to give it a sudo. And we just wait a little bit. Okay. And now let's go ping Google. And we can see we can ping Google. All right.
Nice demonstration. I like that. Yeah.
If you change your IP address and you can't get to the outside world, go DH client or sudo DH client, right? And then if we go ifconfig now, we should see that interface, it still shows it as unfortunately, it still shows it as have that static, but obviously it's not using that one. Sometimes it takes a little while for it to change, but we can test to see that it's configured by simply saying, yeah, there we are. We can go out to the outside world. So we're no longer using a static IP address. Sometimes it takes a little while before it actually changes it, but it does work. So that's the important part. Then what we might want to do is DNS. Basically, it's the protocol that we use to be able to convert IP addresses into domains. Right? So we don't have to remember all these IP addresses. So we don't have to remember that Google's at 142.250.217.142, right? I don't care how good a memory you have, you're not going to remember all those IP addresses. And so the internet gods put together a system called DNS, where basically what happens is that the IP address gets converted into a domain, name, okay, so that we can just type in google.com and not have to remember what the IP address is. It translates the domain into an IP address, because the internet is based upon IP addresses, right? It's not based, there's not these names floating around the internet. There's IP addresses that are available on the internet, and the DNS service converts what you want, Microsoft.com, KaliLinux.org, Google.com, into an IP address, and then reaches out to that IP address. So that's how we go ahead and do that. Now, we can go ahead and explore the DNS. We're using a command called dig. And so we can go ahead and go Microsoft. Oh, let's pick on Tesla. Everybody loves to pick on Tesla now. It used to be everybody used to love to pick on Microsoft. Now everybody's picking on Tesla. So we'll pick on Tesla too. And since Elon Musk is the richest man in the world, he can take a little bit of easing. So let's go dig tesla.com. And what we find out when we do that is that we find out, essentially, let's go back to the command, dig tesla.com NS, name server. And so we can see here the name servers for Tesla. We can also use the same command. I'm going to use up arrow and go MX, and I can see the mail servers for, here's the mail server for Tesla. We can also then go ahead and, well, let's talk about something that's often overlooked in a lot of people's understanding of how their system works. Whether you know it or not, there's actually what's referred to as a host file on both your Windows systems and in your Linux system that your system looks at first before it goes out to a DNS server. So let's take a look at that. Let's take a look at that file. We'll go sudo mousepad, and we're going to go etc. And well, first of all, we're going to look at this case. Let's look at the DNS server. What this does is this file tells the system where to look for the DNS server. And you see it right here. The name server is 192.168.107.2. Now, yours might be different. Everybody's going to be different on this. All right. And this is where it's going out to look for your DNS server on your network. Now, you can change it to, for instance, you can change it to whoever your ISP's DNS server, wherever your corporate DNS server is. In this case, because I'm using a virtual machine, it's using a virtual machine's DNS server. So I can go ahead and change that DNS server by just putting in, say, I've forgotten whose DNS server is. This is Google's DNS server. That's Google's DNS server. And we can go ahead and save that file and then close that file. And now, if I still go, say, ping Google, it should still work. Yep. So I'm using a different DNS server now and it still works. So sometimes, you might want to use a DNS server that's closer to you to get a faster response time. DNS, by the way, uses UDP in the traffic between you and the server. All right. So this can be important when you're trying to analyze traffic between, on your network. If you're looking for like port 53, which is DNS, and you're looking for TCP traffic, you're not going to see your DNS traffic, right? You got to go to look at the UDP traffic. Now, we're talking about doing some basic networking. And one of the things that you need to do as a hacker or network engineer is to understand some basic NMap. So let's talk about NMap right now. NMap is a real simple tool. It's been around for over 20 years. And basically what it does is it goes out to your target, tries to determine whether or not what ports are open. Why do we care what ports are open? Because if we're attacking the system, usually we're attacking the services behind the ports. It's a way to know what's being run on that system. This is one of the first things you do in active reconnaissance. There's lots of information you can get from passive reconnaissance, from third-party sources, But ports being open, you can get that from Shodan, but Shodan sometimes is a little bit old. You'll find sometimes when you go to Shodan to find out what ports are open, Shodan scans the world and it takes a few weeks before it catches up. So sometimes the data is a little bit old. Also, if you're talking about your own local area network and you're trying to scan your local area network, NMap's a good way to find out what ports are open. Ports usually mean services behind ports, what services run behind those ports. So NMap's a great tool. Let's go ahead and just do the -H. Let's see. Yep, there it is. -H for the NMap screen. This is the NMap help screen. There's a lot of information here, but really we can boil it down to real simple. All right, so basically NMap is the command NMap, the type of scan, that's the S, some other options, and then the target, so that you can basically do a scan NMap, then the type of scan dash lowercase s, and then usually an uppercase letter. Here's the scan techniques right here. The ones that you probably should be most familiar with are -SS, -ST, and -SU. There's lots of others that we can do, and they get a little fancy, these Christmas scans and what have you, which for whatever reason, all of the hacker books talk about the Xmas scan, but
exactly,
you're not gonna find it very useful, all right? Despite what the books say, all right? But here's the basic example right here, all right? Is B-A, and then the specification for the target. It can be either a domain name or it can be an IP address. I've got another system on here that. Let me get the IP address. This is another Kali system right over here. And we're going to just use NMap on it. All right. The IP address on it is 192.107.141. So let's go and ping it, make sure that it's actually up. Okay. Because you can't hack anything that you can't ping. Well, that's not true. That you can't hack anything that you can't connect to. And the reason I backed away from that statement is that
I was going to say, firewalls.
A lot of network engineers, security engineers block ping or they drop pings. So just because when you send out a ping and it says the host is not up, it doesn't mean that it's not up. It may mean that the network engineer has done the smart thing, which is simply dropping the pings, right? So you can't tell whether or not it's there. But that gets into a little bit more advanced stuff than what we're doing here today, and we'll address that in another. This just tells me that I can ping that machine, which means that I can connect to it. Now, as you know, there's TCP IP. These are the protocols that are most widely used for connection over the internet. They've been around for a long time. We talked about the IP address, but also what we need to think about is the three-way handshake. This is the three-way handshake that's in TCP. So what it does is that when it sends out, you're the client, when you send out a packet to any server, the first thing it does is it sends out that packet with a flag, okay, set, a SYN flag set. We'll look at what that is in just a minute. A SYN flag going out to this server that says, I want to open a connection to you. SYN's probably short for synchronize. So sends out a packets with the SYN flag set. If the server is accepting connections on that port, okay, on that IP address, it'll come back with a SYN ACK. So that has two flags set on it. And then you will come back and send out all your packets after that with an ACK set. All of your packets after that will have an ACK connected to it. So that's what's referred to as the three-way handshake of TCP IP. Right? This is a way that we connect to any server before we go ahead and do any work, okay, put any traffic on a server. First thing it does is it has to go through this three-way handshake. This can be useful information to us as hackers, network engineers, because we can use this information to determine what ports and other information about this system. We know a little bit then about what the three-way handshake is. So let's take a look at the TCP IP header. Here's a TCP IP header. And you can see this is is a combination here of both. This is the IP header. Remember, these are two separate protocols. There's the Internet Protocol and there's the TCP protocol. And usually they work together. Not always, but usually they work together, right? And on the IP protocol, the thing that's most important for us to point out now is that you have a source address and a destination address. But when we get down to the TCP header, this is where we define the source port and destination port. That's where is it going to and where is it coming back to. You can see, we'll talk maybe more later about the sequence number and acknowledgement, but what I want to point out right now, these right here, these are the flags. These are the way that's defined in TCP IP by the TCP IP gods. They've defined that the way that a system tells another system what its intentions are is by setting these flags. So that if I want to open up a connection, I go SYN. Okay, that says, hey, I want to talk to you. All right. And then the system will respond back. We saw this earlier with an ACK, a SYN, and an ACK. All right. And then everything on that established connection has an ACK flag. These are simply an area in the TCP header where there's a single bit. It's either on or off. If it's on, a 1, that means it's a SYN. If it's in this position right here, the SYN flag. Without going into too deep about it, you can see here, there's a one here that's a bin flag. This means I want to close the connection. And then you can also see here that there's a reset. That's what RST stands for. And basically, this is the way that a system will communicate back to someone and says, hey, this port that you're trying to connect to is not there. It's not open. It's not available for business. So it's a way to say, nope, you're in the wrong place. And so NMap uses this information. NMap is built to use this information to help us determine what the target looks like. So let's go and do a simple scan of our other machine over here. Now I'm going to use the simplest type of scan and probably the most useful type of scan. This is the ST scan. This says scan and use the TCP three-way handshake. The reason that this is the best scan is because it is probably the most reliable. It's going to give us the best information. So it goes out to each port and tries to make a three-way handshake. Remember, we saw that, the SYN, ACK, ACK. If it can't make a three-way handshake, then it says the port's closed. If it goes out to a port and it gets a reset back, that means I'm closed. I'm not open for business. You know, this is not a place. You're in the wrong place. So let's go ahead and look at this other machine and go 192, 168. What was it? 107, 141 was our other machine. You see it right there. And if we do the NMap scan on it, it comes back and says, oh, port 80 is open. Port 80, we know, is HTTP. Now, I think that there is another port open on that machine. I think there's port 53 open. Sometimes NMap will make a mistake. It does do that. Okay, it's not perfect. But sometimes if you're pretty sure there's a port open, you might want to just go put the -P. That says, just check that one port. Okay? When I do it without a port number, what it does is it goes and checks the top 1,000 ports. So this is important to note as well, right? So is that it only goes through what's the most commonly used ports, the top 1,000. You know that ports have 16 bits. That means there's 65,536. So that's a lot of ports, 65,536. I got it right this time, I think. And so rather than scan all of those, ports, it just does, hey, let's just go check the top 1,000. So when you're looking for maybe a more obscure port, it's not going to find it because it doesn't look there. But you can always tell NMap, go check this port. And I'm going to go check port 53, right, is DNS, and let's see if it's open. No, it says it's closed. So let's go back over to the other machine and open it. Now, what I'm going to do over here is I've got Apache running on this system.
Yep.
Okay. And I'm going to clear my screen. Okay. So on this system here, what I'm going to do is I'm going to open up just a little tool that's built into Kali and a lot of the other Linuxes and Unixes called Netcat. Okay.
Yep.
And Netcat is a tool that's real simple that will allow you to open up a port for listening or for connecting. It just opens up a simple TCP connection. So if I want to open up a listener on this machine, I can go at netcat listen, okay, on port, and let's say port 53. It says permission denied. That means I have to use sudo. Okay, so what it's done is it's now opened up port 53, but waiting for somebody to connect to it. Right? It allows me to connect to it. Now, if I do my NMap scan, right, let's just do a quick scan again, and you can see, oh, look at that. I've got port 53 open.
Nice.
All right. So this is a way that we can discover what ports are open on our target system. It's not perfect, but it's a good, simple tool that allows us to determine what's out there. Now, one of the things that you'll see when using NMap is that in this case, it says port 53 is open right here. Sometimes it'll say closed, and sometimes it'll say filtered, which means that there's a firewall there. Or sometimes it'll say, I don't really know. It's either open or filtered, or it's closed and filtered. We can't really tell from the information that we've gotten, but it's one of those two. So, but it also tells you, since this port 53 is open, it tells you that it's a domain server or a DNS server. Now, what NMap does is it uses the default services. So if it finds port 53 open, it says, oh, that's a DNS server, right? Because that's what 53 is used for. But we know just from a minute ago that that's not true. So it's only going back and giving us the default service on that port. And sometimes it's not accurate. If you want to get a more accurate view, is you can use the -A switch. Okay, right here. And what this will do is it'll go in and probe each one of those ports and try to determine exactly what service is running on it and what version of that service is running on it. This simply is saying, oh, it's port 53, so it must be DNS. It's port 80, it must be HTTP. It may not be, because as you know, a network engineer can put any service on any port. So for instance, your particular organization might put HTTP on 8080. That's commonly used, right? So you can put anything on any port. This just shows you the default service for that port. And sometimes as a network engineer, it's advisable to put your services on something other than the default port. Why? Because a hacker like me, when I go and scan your system and I see port 3306 open, I go, oh, that's MySQL. I know you got MySQL running on your system. Thank you very much. But if you go and put that same service on port 555, I look at that and go, I don't know what that is, right? Until I scan deeper. So if I go ahead and scan a little deeper here, this takes a little longer, because it's doing more work. It's not just sending out the three-way handshake. It's actually probing to determine what's running on that. So it comes back and looks like it didn't know what to make of port 53, which is understandable because it's simply netcat. But it did give me a lot more information, okay, about the Apache server. It told me what version it is, what operating system it's using, and it tells me what the default page looks like, and it says it works. And anybody who's used the Apache web server knows that that's the default page. As a matter of fact, we can take a look at it, and let's go use our browser and connect to that machine. And that's the default page for Apache. If you're 192, 168, 107, 141. So if I go ahead and use a browser, I can put in the IP address. If we're trying to connect to port 80 or 443, the defaults for HTTP and HTTPS, you don't have to put a port number in. But if you're trying to go to a different port, you must put the port number in. It would be like this, like 8080, like that. But in our case, we're just trying to connect to port 80, so we don't need to put any port in at all, and just hit enter. And wait, there it is. That's the Apache 2 default web page. Later on, we get later in the book, we'll play a little bit with that Apache server. Apache is the most widely used web server in the world. Nginx is coming on fast. Lightspeed, IIS, those are the major ones. But Apache has been around for 25 years or longer, and it's still the most widely used. It used to be like 60 to 70%. I think now it's down to about 40%, but it's still widely used. And it's free, and you can use it on your system. And we'll make some basic web pages later on in class, all right? And this can be really useful, as we'll see, in doing lots of nefarious work on your network. So that's what it looks like from the attacker perspective. Now, let's go over to the victim, and let's open up a tool that everybody should be familiar with. It's a tool. It's one of my top 10 hacker network engineering tools, and that is Wireshark. I'd include NMap in that top 10 as well. NMap, you need to know the basics of NMap. You need to know the basics of Wireshark. If you don't, it's going to be really hard to be successful in this field. So let's take a look at Wireshark. I can just go ahead and let's go to, I can just do it by going Wireshark, right, like this. I don't need to go to any GUI, and it'll start the Wireshark. And here's Wireshark right here. And let's go ahead and tell it what interface I want to work with. Okay, ETH0. And you can see there's nothing coming up on it. Here we got some little, this is all kind of, you can see this is Dropbox Discovery, some other graphic that's on there. Takes a little while to come up. Now, let's go over to our Kali system, and let's go, and first of all, let's just ping that system. We talked about pinging, right? Let's see what that looks like from over here. Can you see these here? This is coming from my attacker system to my target system. It's going back and forth. It's going ICMP, echo request, echo reply, from one IP address to the other IP address. And this is a really, really useful tool that you should become familiar with. And notice that on Linux, the pings will go continuously until you stop them. In Windows system, they'll send out 4 packets, and they'll stop. In Linux systems, you can see it's still going. It'll just keep on going until you stop. Linux and Unix. Now let's go ahead and take a look at the NMap scan. So let's go ahead and send that, and let's go back over here, and you can begin to see that the protocol has changed from what had been ICMP to TCP, and it's trying to go out and determine what ports are open. If you look closely, you'll see that it's going through multiple ports, and it's going to try to discover what ports are open, and then what services are being run on those ports. Right? You can see that here's the fin ACK, here's the ACK, here's a fin ACK, SYN, ACK. That's that one flag that we talked about in TCP that I think you should be familiar with, but surprisingly, a lot of people are not. Here you can see the ARP, okay?
Yep.
ARP basically is going out and discovering who has what IP address on what MAC address, and that's what's going on. So this is a really, really useful tool. This is the live feed you can see here. Here's DHCP going out here. We can click on any one of these packets, and it'll go and show us more details. We can expand each of these. Notice it's the DHCP is using user datagram protocol, source port 68, destination port 67. And over here, we can see here's the IP header and all the information about there. And then down below, we have it in hexadecimal and an ASCII over here. ASCII is what we refer to as human readable language, right? Stuff that is using, it's using letters that we know and familiar with, all right?
Exactly.
Let's see, here's our scan. Also, I want to point out that, a lot of hacker books talk about using SS, right, to do a scan. And that's great. Okay, the difference between an ST and an SS scan is that an SS scan doesn't open up the 3-way handshake. It does not open up the 3-way handshake. Why is that important? Because generally the web server, right, will log the IP address of anybody who makes a 3-way handshake. That's true, but the security devices on the perimeter of the network are recording everybody's IP address. So watch here. So this is our stealthy scan that every one of those hacker books says you need to do if you want to remain anonymous. But if I go over here, let me get the sudo, there we go, and watch what's happening. Yeah, I'm not very anonymous. I can see exactly your IP address. So any idea that the SS scan is stealthy, and that's what a lot of the books call it, is the stealthy scan. Well, really, it's actually a SYN scan, but a lot of books call it a stealthy scan because your IP address is not going to get logged. But in reality, your IP address is just as visible with a SS scan as it is with an ST scan. So my thoughts are it's a waste of time doing an SS scan because it's not hiding your IP address. It's still going to be discoverable. Here we can see that even in Wireshark, it's showing me the IP address from that scan. So it's not very stealthy. But so just kind of take some of the things that you read in some of those books, not my books, but other people's books. take theirs with a grain of salt because some of the things just don't work. And this is one of those things that, I don't know, it's a minor thing. But I know I've had students in my class go, why don't you use an SS scan? Why do you use an ST scan? Wouldn't you be more stealthy with an SS scan? The answer is no, I'm not more stealthy with an SS scan. So it's not going to hurt to do an SS scan, but it's not really, you're not going to benefit at all from it because any kind, whether it be an IDS, whether it be a firewall, whether it be the network engineer, whether it be any type of device that's watching the packets is going to see your IP address, right? It's attached to every packet. The only thing that it's doing is that it will not make a three-way handshake. So the web server won't log your log. It'll still see your IP address. It just won't log your IP address.
That's why it's important to know Wireshark, right? Because then you can see what's actually going on versus the theory in a book.
Exactly. So here, this theory is, that if you use the SS scan, you're stealthy. We use Wireshark, and we can see that the IP address is totally visible on the target system. So that's pretty much, the two of the most basic tools that we want to go ahead and be familiar with. I'll put it on my top 10 cybersecurity tools is Wireshark and NMap. I think, David, you've got other speakers who have done videos on both of these subjects.
Yeah, Chris Greer's a big Wireshark guy, so I'll link some of his videos below if you really want to get into Wireshark at like crazy detailed level. Have a look at those videos. Yep, sorry.
He's got some great videos on your channel. And then NMap, I think you have some NMap videos as well. And we do that as part of our introductory level classes at Hackers Arise. But those are two of the key tools. We learned a little basic networking. We learned how to discover our IP address, how to change our IP address. Oh, one other thing that we might want to do, let's just kind of keep, is that we can change the MAC address as well.
Just gonna ask you that.
Yes, we changed our IP address, but we might want to change our MAC address. MAC address is the globally unique address that is attached to every network device. And one of the reasons that you might want to change your MAC address is that, well, for example, if I was using somebody else's or trying to use somebody else's Wi-Fi access point, generally, the network engineers who set up Wi-Fi access points, one of the cardinal rules is to be able to keep it safe, is to limit who can connect to the Wi-Fi access point by MAC address. So, okay, I've got 10 people in my office. I get all their MAC addresses, and then I put it into the Wi-Fi AP and say, only these people can connect to the Wi-Fi. But I can go ahead and change my MAC address to look just the same as one of those people who are allowed to use the Wi-Fi. How do I do that? Okay, first thing we got to do is go ifconfig, and we're going to go Ethernet 0. That's my Ethernet adapter. I'm going to take it down. And of course, it tells me that I have to use sudo to do that. All right. It doesn't want just anybody. It doesn't want anybody taking down. It wants only the root guy or gal, the root user. Okay. So now my Ethernet adapter is down. If I go if config, it's not going to show up there. You can see it's not there anymore. I've taken it down. Then what I want to do is use the same command. I use sudo, of course, because this is stuff that the system doesn't want just anybody messing with. And then I go ETH0, and then I'm going to assign it, okay, a hardware address, okay, and then let's use a real simple and easy to distinguish hardware address. This is MAC address. When we say hardware address, we're talking about MAC address. And this is a globally unique address. Normally, you can see here's one right here. This is for the Wi-Fi adapter. So it's usually in hexadecimal, so it uses 0 through 9, and then A, B, C, D, E, and F, right? And so I'm just going to assign it a random number. Like, as a matter of fact, let's go ahead and now let's do the ETH0, and we want to assign it that IP address. It says it cannot assign the requested address. Let's change it to there we go. It recognized that my 00000 address was not a legitimate address, right? Now, let's assume that this is an address that I've discovered that is on the whitelist of the AP. Whitelist is the addresses that can connect to it. So now that I've changed my hardware address, I can connect to the Wi-Fi AP as well. So now if I go if config ETH0 up, all right, and of course I have to use the sudo.
I can see you've been doing this for a long time, because in the old days you just root, right?
I've been doing it for a long time, and I've never really fully adapted to having to use sudo all the time, because as a hacker, I'm usually always operating in root mode, and my inclination is to switch over to the root user and just do everything from there. But in teaching classes, I think it's probably a good idea to use sudo so that the students don't go ahead and switch over to root and then end up getting themselves hacked. So now let's go ahead and do ifconfig. And now let's go up to our ETH0. There it is. And you can see I've changed the MAC address. All right. So let me repeat why this is important, because many of the security engineers who set up Wi-Fi access points put in a whitelist based upon the MAC address, And so it keeps everybody out but the people who have those MAC addresses. If I know their MAC addresses, and I can show you in the future tutorial how you can discover them, then I can simply emulate. I can replicate their MAC address on my system so that my system looks like one of those systems that's allowed to access the Wi-Fi access point. It's also really useful for Wi-Fi hacking, not only for accessing, but for Wi-Fi hacking, because sometimes you need to replicate a user's MAC address to be able, for instance, to knock them off their Wi-Fi. Sometimes you can knock somebody off the Wi-Fi AP or use their MAC address to be able to do things to the Wi-Fi AP that will help you hack that system.
That's brilliant. Occupy the Web, thanks so much for sharing. I always say this, someone who really, really knows what they're doing can explain it simply. And I love the way that you can bring it down. So you obviously know huge amounts, but you explained it in simple terms. So really appreciate you doing that. Thanks so much. For everyone who's watching, please put comments below, stuff that you want us to see, or stuff that you want to see, stuff that you want us to cover. We've got a whole bunch of ideas. Occupy the Web, I really appreciate you doing this. Thank you.
Thanks, David. I always appreciate being on your show, and I look forward to our next meeting.